Okay, so hello and welcome back. So in this video we want to basically work a little bit on exercise 1.3. Exercise 1.3. Let's see what we have there. So we have basically question number 1. We have let f be equal, let f be, so we have let f be basically a well, it's supposed to be a function, of course, most probably, as far as I can tell, to basically 1, 2, and 5, and g is basically another function from 1, 2, 5 to 1, 3, 1, 2, 5 to 1, 3, and f of f is basically f is equal to this set, which is 1, 2 and 3, 5 and 4, 1. And g is the same thing as 1, 3 and 2, 3 and 5, 1 and 5, 1. Right? You want to write GOF. You want to write down GOF. So GOF is basically the function that takes you from f to basically that takes you from, so you see that f takes you from this set. Let me rewrite this problem. So you can see that basically f takes you, let's say that this set over here, let's call it A, for example. A is equal to 1, 3 and 4. And let's say that B is equal to this set over here, 1, 2 and 5. And let's say that, for example, C is equal to 1, 3. 1, 3, right? So that means that f takes you from A to B. F takes you from A to B. And, well, that is f basically. That f is this function up here. And g takes you from basically, takes you from B to C. G takes you from B to C. Meaning that if I have the set A over here, which is 1, 3 and 4, right? And this is set A, this set B is 1, 2 and 5, and this is B, and 1, 3 C. So you can see that f basically is a function that goes from basically A to B, which means that it gives me, this is f from A to B. So that gives me basically 1 map to 2, 3 map to 5, and 4 map to 1. So you can see that it's a function 1, 1, and even surjective, and so bijective as well. So we have no problem there. This is basically f. Now we have also g, which takes us from basically from B to C. G is this function that takes us from B to C. And so it's basically 1 to 3, 2 to 3, right? And 5 to 1. So again, it's basically it's of course not a 1, 1 function, but it's many 1 function. But then on the other hand, it is surjective and it is a function, we have no problem with it. Now, basically GOF is a function that takes you from GOF is basically the same thing as G of f of x, is the same thing as G of, but if I write this as GOF of for example of some variable x, some arbitrary variable, that is the same thing as G of f of x. That is the same thing as G of f of x, which means that basically, for example, this 2 is the same thing as f of 1, of course, meaning that if I call this x, then this is going to be f of x, and it's basically going to be something like this, meaning that let's say that you have your set A over here, and you have your set B over here, and you have your set C over here, and let's say that you have your x over here, and this is the f and this is g. So basically under f, x is mapped to f of x in B, right? And then under g, f of x is mapped to g of f of x, g of f of x. So we can see that g of f of x is basically which is basically the same thing as GOF. So what that means is that GOF. Okay, so let me see. Okay, so basically what that means is that G of f of x, as you can see, is the function that takes you straight from here to here. The argument is x, and the output is basically GOF, right? Now, what happens here is that so that means that basically the function GOF basically in this particular situation is basically this function that takes you from here to here, which is GOF, which means that basically then, for example, you see that f of 1 is equal to 2 and g of 2 is equal to 3, right? F of 1 is equal to 2 and g of 2 is equal to 3. G of 2 is equal to 3. And so then basically GOF of 1 is the same thing as basically G of f of 1, which is the same thing as f of 1 is equal to 2, which means that G of basically G of 2 and G of 2 is equal to 3. As you can see, this function gives you the output, takes you from here straight up to here. Or for example, this member of the set A, which is equal to 3, so f of 3 is equal to 5. So you can see that f of 3 is equal to 5, and g of 5 is equal to 1. G of 5 is equal to 1. Now, GOF of 3 is the same thing as G of f of 3, right? Which is equal to f of 3 is equal to 5, so that's G of 5, and G of 5 is equal to 1. And you can see that you can see the GOF of 3 is equal to 1. And also And also we have another basically you have 3 and 1, 3 and 4. So you see that f of 4 is equal to 1. You see that f of 4 is equal to 1. And g of 1 is equal to 3. G of 1 is equal to 3. So G of 1 is equal to 3. So now GOF of 4, GOF of 4 is the same thing as G of F of 4, is the same thing as G of F of 4, which is the same thing as basically F of 4 is equal to 1, so that's the same thing as G of 1, and G of 1 is equal to 3. So then in basically this is basically what we were looking for. So we were looking for GOF of 1 is equal to 3, GOF of 1 is equal to 3, GOF of 3 is equal to 1, GOF of 3 is equal to 1, and also GOF of 4 is equal to 3. That is basically the values that we were looking for. So let me take a look at the solutions here. I want to make sure that we didn't make any mistakes. 1.3. So one additional thing that we can do here, we can write GOF as a set, of course, as a set of ordered pairs, meaning that I can write GOF as a set of ordered pairs, as for example 1, 3 and 3, 1 and 3, 1 and 4, 3 and 4, 3. So 1, 3, 3, 1, 4, 3, and that is the correct answer here.